Set the stage a bit. I mean, CDI, Circular Drive Initiative, is designed, to promote the reuse of storage devices, and this, introduces, companies to a lot of different business opportunities and topics that are of interest. And so today we decided to have a discussion on the rapid growth of AI infrastructure. And so we have two people who are in this space and are subject matter experts, Jonmichael Hens from Farm GPU, and then Nick Sedar from HydraHost. Maybe what we can do is just have a brief introduction of yourself and your company, and then and then after that we can get into one of our first topic questions. So JM, can you give us a quick intro?
Yeah, so as you guys know, I wear many hats. The one that's consuming the overwhelming majority of my time right now is a CEO of a company called Farm GPU. So we are a AI cloud, a neo cloud that's hosting GPU and AI workloads. And one of our fun angles is obviously I have a lifetime background in storage, so we're doing a tremendous amount of stuff on AI and storage. And some of the things I can kind of discuss today is we've been talking a lot about the impact of storage and AI and what that means and what how it ties into the rest of the stuff. And I know just getting a lot of firsthand experience. We're in the process of building an AI data center out in Rancho Cordova, California. I'm here at the Solidheim office. We have a collaboration and partnership with Solidheim, for their AI lab, and lots of fun stuff going on. So,
Thank you. Nick?
Yeah. So it's good to meet everybody. So Nick Sedar, I lead business development and AI factories over here at HydraHost. So we're basically a phase ahead of before Farm GPU. So essentially what we're doing is we manage AI factories, and these factories are not managed by HydraHost directly. They are owned and operated by the title owner of the hardware. So we are an NVIDIA cloud partner that technically doesn't own any hardware. We're like the Airbnb of GPUs. So the individuals that I typically work with are new AI factories that are interested in stepping foot into the AI or AI ecosystem, HPC ecosystem, and they want to buy their first GPU purchases with expectation that they're going to monetize those through the HydraHost platform. So we have three areas of business. One side is the AI factory, the data center supplier that we work with. Right now we have over 20,000, 22,000 GPUs under management, ranging from 3090s all the way up to the B200s, especially eventually the RTX Pro as it comes out, and then the B300 as well. We have one side of the organization that's fully responsible for managing demand customers, individuals that need access to additional compute, people like Farm GPU, people like the Lambda Labs of the world, individuals that need access to large-scale clusters, either on demand or term. And then we have an area of the organization that's focused specifically on procurement, both new hardware as well as used hardware. And we can dive into all of that today.
Yeah, excellent. Thank you for the introduction and the explanation. Maybe we can get you guys to talk a little bit about the dynamics. Obviously HydraHost has a niche, and you explained it well. Farm GPU has a niche as well. Where do the hyperscalers fit into the use of with their AI servers? Can you tell us a bit, what does the dynamics of this AI server industry look like? I mean, there's a lot of different players, but maybe you can kind of simplify that for the members here.
Yeah,
JM,
I
go
can
for
say,
it.
yeah. Honestly, Mark, I was gonna even gonna start. I did I don't know if you guys saw. I did do like a little thing for SNEA a couple weeks ago on AI data centers. So I can send the YouTube link. But this was really just kind of like capturing some of this stuff, like on the first of like what is an AI data center. I think that there's a lot of I think this is a really important distinction because as we just throw around the word AI data center, but there is a massive shift going on. It's like how data centers are built. And obviously, like on the storage side, and all of us that are in this circularity and sustainability space, this has a massive impact. Like the way I described this in this little webinar was like, when I hear AI data center, the first thing is really running AI workloads. So that's training, inference, fine tuning. And how do you do that? You need GPUs, accelerators. These are now the star of the show and dominate the CapEx. And it's very memory heavy, high speed networking. The biggest highlights that are kind of massive impacts to data centers and the infrastructure is the high power racks and the high density. And this is really just about CapEx density. And this is part of, I can kind of walk through the rest of the presentation, which is like just how far they're pushing. But typical like colo type data centers might have been 5 to 20 kilowatts per rack. 20 kilowatt rack would have been considered like a very dense high power rack. And now in the AI space, 40 to 100, 120 plus kilowatt is the average. And hyperscalers are pushing to up to megawatt racks, which it's in the next 3 years, which is just completely mind bending. And then the other major change that goes along with that is that when you have these extremely dense racks, that your liquid cooling is now basically essential. There's two direct to chip is what most NVIDIA is kind of going to for all their reference designs, and then there's still a lot of folks, especially it's in the sustainability side in OCP that spent a long time on immersion cooling, and so these aren't nice to haves anymore for AI data centers. They're absolutely required, and so this basically is a long way of saying, basically the entire data center has to be re-architected and redone. And then there's a lot of impact on essentially, right, like where there was this, certainly a lot of the folks here that are spent time in the ITAD world of like, how does this affect the secondhand market? How does this, affect, new data center builds? As Parker mentioned, like, okay, well, the hyperscalers are just dominating the CapEx spend, right? As far as, we heard something along the lines of like, I think like 70% of the revenue right now from NVIDIA is coming from the hyperscalers. And, they're buying these, racks that are 132 kilowatt racks, buying them at the, at the rack scale, right? And there's still a lot of other data centers like us that are doing the long tail of supporting AI developers that, are not like, buying, $3.5 million rack as our minimum order of purchase. Anyways, yeah, there's lots more fun stuff in this presentation I can go into, but for now, I'll hand it over to Nick.
Yeah, just real quick, and perhaps Nick can touch a little bit on this. You described that 70%, share going to the hyperscalers. This 30%, who lives in this world?
Yeah, it's kind of interesting. CoreWeave and Nebius and these guys used to be, considered neoclouds. Now that I think they're big enough, obviously, where CoreWeave is kind of considered a hyperscaler. But really, the idea was that these companies that are challenging the traditional hyperscalers in the cloud business model for renting GPUs, and a lot of them like AWS and and Azure, don't just sell compute instances, they sell storage, they sell database, they sell in a whole entire suite of cloud products. So now I think we're seeing there's when I don't know if a lot of the folks have heard the word neocloud, but this is a term coined by SemiAnalysis to basically describe this new set of requirements for that are data centers that are focused on GPU and AI computing. And again, it's also not obvious how these neoclouds can take on these major hyperscalers and cloud service providers head to head. But when you peel back the onion on all the platform tools and stuff that NVIDIA and company has provided to folks, this AI reset that I just described kind of sort of levels the playing field to where all this legacy infrastructure at the hyperscalers was set up for for traditional computing, and obviously they're building out AI data centers for at hyperscale for training, but there's this other long tail of a bunch of enterprises that need private AI workloads. We're talking to partners right now that might want to build a bunch of storage and have that local to the GPUs so that they can do the computing. If it wasn't obvious from that last slide I had, that all workloads will be touched by AI one way or another. So there is not like going to be any more traditional workloads that just sit in isolation. They have to be, GPUs are the star of the show in the data center now by CapEx, and that doesn't mean storage and networking and other things aren't important. They're just most of the money is going to compute. It's going to the GPUs. So
Thank you. Yeah, Nick, you'd like to comment?
Yeah, to double back on your question, I wanted to share a quick screen as well. So you asked where we fit in. This is the image that I typically share to most individuals. These Hydra hosts, if you see down on the right, we consider ourselves the crude oil for the refinery process. Right? So HydroHost is bare metal as a service. On the left, hyperscalers, they cover it all. Once you get in bed with the hyperscalers, you're in there forever. I come from the AWS ecosystem. It's so easy to do business with somebody like an AWS. They they value you as a partner. They help you grow as a partner as you scale. Many of the challenges come down to the monetization or the budget that some of these new AI startups that HydroHost works with, they aren't fully committed to somebody like an Azure or AWS. So they're starting to piecemeal together the proper solution that fits an AI native technology or a sovereign AI business case. So to us, the hyperscalers weren't officially tailored towards the sovereign AI case. So HydroHost, when we were founded about 4 years ago, we saw a major market for specifically bare metal as a service. Many of the end customers that are tapping into the HydroHost supply, that supply is international. Again, these data centers, we don't own them. We are essentially the go-to market channel for data centers that want to monetize their hardware and provide it to the masses. So we have end customers that are tapping into our resources that are building out their own inference and training models. We have AI major neo clouds such as BitTensor, Together AI, Parasail, RunPod. These individuals are tapping into additional supply because some of them own their own supply, but also they need to tap in. Their demand well outweighs the supply that they have on site. So to us, or to me, what I typically present, the barrier of entry for AI products to enter the market today has become so low that you can sign up for someone like a parasail.com. You can start running your own small language models and your own inference related platforms as quick as a week, right? The hard part is owning the hardware and building out the data center and owning the real estate, owning the energy, installing your own GPUs, and then taking that to market, right? So Farm GPU, you guys are doing the entire gamut. Like you're doing something that not everyone has that capability to do. And so to us, the model that we're very successful with, HydroHost wants to remain the bare metal, wants to remain the crude oil, so that all of these refinery products can then put their own spin on things, manage the end customer, provide their own large language or small language models, their inferencing, their platforms, their ML, and then they pipe it up the stack into the AI tooling realm.
Excellent, excellent. Thank you, thank you. So let's kind of talk about this Blackwell transition in and then its predicted impact on our market. As this transition happens, where do the older architecture, where does that go? Can it still be used? What are some other interesting nuances that you think will happen as this transition occurs?
Yeah, one of the companies we work with on the industry analyst side is SemiAnalysis, right? They're kind of like the primo analyst firm in this AI space, and they have one of their most popular models is their cloud TCO model, and which they have basically a forecasted pricing curve, for these GPU on demand workloads, which again, right, most of the CapEx is going to the GPUs right now. The typical pricing for how these can be monetized are looking at like the dollar per GPU per hour. And they have this curve that declines over a specific amount of years, and it starts high, and then there's a lot of debate on how fast that declines. And as NVIDIA and other folks release new products like these Blackwell, Jensen went up on stage at GTC and said, "Yeah, we have this new enterprise thing, these RTX Pro 6000 Blackwell, and 8 of them, is 1.8x the performance or 1.7x the performance of an H100 HGX, which a few years ago was 2 years ago was $400,000 for the server." And now you can buy this new server that supposedly is 1.7x the performance of that for $90,000. So holy moly, what is the impact of this? I don't think we've seen quite yet. Now, I don't think that there was tens of billions of dollars of money spent on H100s. Even like most of the hyperscalers like Meta and X.AI just installed theirs in November and December. So does that mean they're going to like turn them off because there's these new things out there? No, but there are companies that ran them for a couple of years, and I think are going to be in the spot where they're like, okay, well, we tried this thing, and maybe maybe we decided the cloud is easier, or maybe we decided something else. Like, so we're just now entering the phase where there just wasn't that many A100s comparatively, like as far as like in the drive world. Maybe it's a little different in the drive world, right? There's only in the hard drive guys world, there was two major suppliers, and it was pretty well understood market. And with the GPUs, it's like a very specific model number, like H100 is drove tens of billions of dollars of revenue for NVIDIA last year. And I think we're just starting to see these first like secondhand ones hit the market. And the funny thing is when we talk about like circularity and reuse and storage is the hardest because these are storing user data. Like one of the interesting metrics I was showing as far as like this is just a interesting way to look at it because from a storage vendor standpoint, they want to know like how much money are people spending on storage in AI, and in a typical training server. This was based on like an H200 HGX, and the accelerators, the GPUs were 80% of the BOM cost on the server, whereas traditional servers, it was kind of a mix of CPU and networking and DRAM and storage. And on storage servers, the storage was 60% of the cost of a storage server, right? But on AI servers, now storage is now like 1 to 2% of the entire BOM cost. Like it's a very tiny amount. But that's a long way of saying doesn't mean storage is not important. It's just in the AI world, like I said, secondhand storage was like people kind of knew how to price it and how to, there's this like dollar per gigabyte, and I think we're still seeing in the AI world like okay, like what is how is the market going to shake out? Um,
Thank you.
That's interesting to me because you're solidifying my viewpoint on the fact because you and I are both in this demand market, right? The customers come to us because they need to achieve some sort of use case. And most of the customers that approach HydroHost, they're not typically asking for X amount of Weka or X amount of VAST. They need the local storage. They're looking for a NVIDIA reference architecture with a strong server that can help them perform the tasks that they need to complete. But storage right now for us tends to be an afterthought. Most of the large scale demand customers that are looking for, let's say 64 or 128 nodes of GPUs for 2 years, yeah, they might want to tack on something like, an external storage system like a Weka or a VAST. But the standard inferencing, many of the on-demand style customers, the folks that just need to, they need the power to do their work, they're not looking for it. So you just solidified my viewpoint on the fact.
Yeah. Now, I do think that it's going to change, right? As I'm working with other enterprises, and I'm sure there's a lot of other enterprises that are, not very far along in their AI journey of like still trying to figure out, okay, like where's all our data stored? Oh, some of it's in Azure, some of it's in Jira, some of it's in this database over here, and they have to figure out like how do we get all this in one place so we can actually do AI analytics on it and get some insight out of that data to make business decisions. And it's super hard. Like before, if you yeah, it just made sense to have all your data in these different places. With AI, it actually makes sense to have all your data in one place and have one like single pane of glass. I think we are going to see more enterprises try to figure this out to be like, okay, well, at the end of the day, we don't have that much data. It might be like tens of terabytes or hundreds of terabytes, even for like a big company of like 3 or 4 thousand people. Okay, it might just make sense to put it in one storage array and attach that to the AI cluster, or use it to get analytics out. But yeah, I mean, obviously, like vast data is kind of the star of the show in the storage space for AI right now, as far as growth and valuation, and their kind of software approach to not being so reliant on selling hardware, all flash arrays, right? This is sort of like the all flash array guys have been fighting it out for for years in this space, and now they kind of finally have this killer use case with AI to be like, finally, AI developers don't really want to learn storage. They just want to buy something that works. And that's exactly what we're seeing. Like they just want to buy a solution that works. They're not like building their own or rolling their own or being super cost competitive right now on the storage because it's not a big part of their CapEx spend. They just like, let's buy the thing that everybody else is buying that works. you know, and
Yeah.
today that's the Vast is one of those guys, right?
Yeah, they're all doing something interesting, right? Vidora is making a massive splash in the market. They're doing a few new things. WEC has been doing a lot. Vast obviously owns it right now, but I agree. I think that we're going to see an uptick. In regards to the IRR on that, though, so because I'm working with the AI factories that are looking to launch their own GPU as a service models, my top priority is to make sure IRR stays as high as possible. So the bombs, obviously with the B200, B300, you're looking 300 to $400,000 in server cost, plus all the InfiniBand gear, plus the storage on top of that. And then when you start looking at the rental rates, anywhere between, it depends on depends on what semi-analysis says, but with the B200s, they might rent at, anywhere between 350 to 650, right? For the B200s, it's the massive span where we have to make sure that we're keeping OpEx and CapEx costs at the data center as low as possible so that they can see a return on their investment. Like I said, the barrier of entry to build out a data center is so high. And so adding on all that additional storage, it tends to be a challenge.
So what would be the typical life of an AI server? I mean, is it 3 years and then somebody's ready to upgrade to the next generation?
Mhm.
Then,
Yeah.
what happens to the older server? And one other complexity to this with compliance issues, and maybe the majority of reused material ends up overseas with a commodity that's so controlled like this. Can you comment on the compliance portion
Yeah.
of as
Uh,
well?
at some point, they're AWS, I could say they have a good philosophy on this. Like if it's renting, if it's already deployed in their data center and it's renting for more than the TCO of that for the OpEx, sustained OpEx, they're going to leave it on and just keep generating revenue. Um, Now, at some point when people are running their own stuff, like we're seeing like education, higher education labs, and people doing cutting edge AI research that are like, okay, well, for us, maybe it makes sense to get rid of these V100s or A100s because there's no reason to keep them powered on. Like we're not renting them out in a cloud business model. We're just using it for ourselves. Let's get rid of them and get the new stuff. But as far as like the cloud business models, we definitely see there's definitely a long tail. I think let's look. A100 release date was May 14th of 2020. Um, so, I think there's still a market for A100s, but, now like the generation before the V100s are sort of like, to me, they're kind of e-waste, right? It's just, there's been a considerable amount of, enhancements in that. Was A100 was really their first AI kind of focused thing where they kind of broke out, right? So, okay, where does that put us, right? 5 years, you know, 5 years, and this one's still going good. Will be good for another couple years. My gut feeling says this, 6 to 7 is fairly reasonable. But just like drives, right? There's some drives that are sitting on eBay that are 10 years old, 11 years old. Like, would I recommend those? Probably not. There's been a lot of interesting stuff that happened in the storage world in the last 10 years. That's it's made them a lot better and a lot faster and a lot more secure and new firmware features. So this is just technology. And with AI, now everybody says, oh, NVIDIA is going to go to some one-year cadence that's going to completely obsolete all the hardware instantly. Like that's kind of nonsense. They've basically been telling the entire world what their roadmap is publicly at these large events because they have to. They're building now entire data. People are planning entire data center builds around these GPUs. You can't be a mystery of like, well, oh, what is this going to look like? They're telling you exactly what it's going to look like in 2027. And so with that information, I don't know if I had to, gun to my head, 6 years.
Yeah, I'm with you on the 6 years. So there was just an article that came out where Nebius is uh, doing 4 years. That's their depreciation time. Whereas somebody like a CoreWeave is doing 6 years. We also typically try to keep them as long as possible, but I do have data centers partners that we work with. They try to switch out their hardware every 2 to 3 years just because they're trying to upgrade to the next generation. They're trying to keep themselves a little bit ahead of the curve. They're paying off that hardware in about 18 to 24 months. So that last year of life that before they flip it, they know they're going to still profit. It really depends on who you ask, and it depends on the financial model, right? Again, we're managing IRR so that the data center can continue to make money on this massive investment. So yeah, as the longer for us, the longer you hold it, 5 years, 6 years, we think you're going to be very successful.
Um, Now it is interesting, and then the other side, like I mentioned, there is this long tail of like, lower price instances for these people. There are people that like to run test stuff on like these older cards and whatnot.
Can you guys maybe comment a little bit on the compliance piece of this business?
I actually wanted to double back on one thing real quick, if you don't mind.
Okay, yeah, please. Yeah.
So it's funny you mentioned the V100s. I have a partner that only does second gen. They buy second gen V100s. They rent them through their platform at next to nothing. They are very successful. I don't know anyone else that does it as well as they do. Through the HydroHost platform, our top four selling cards in order: H100, H200, 4090, L40S. L40S has been around for 4 years. That's why we're extremely bullish. You mentioned the question about the Blackwell. We're extremely bullish on the RTX Pro Blackwell series that's coming out here shortly. Right, the server edition or the data center edition is coming out in July. To us, the Blackwell, the B200, B300, obviously it's king. It's great for training, but specifically for the RTX Pro, like you're looking at a Swiss Army knife GPU that's going to be great for image rendering. It's going to be great for inferencing. They talk about it being great for training. In general, I think it's a low cost, low CapEx investment for specifically new data centers trying to enter the market. But we think it's going to have a major upside to a lot of those folks that are still running L40Ss, 4090s, V100s. And it's going to be what, a third of the cost, potentially a quarter of the cost of what a B100 or B200 or B300 is going to cost.
Yeah, interesting. Nice comment. Thank you. Well, guys, thank you very much for your time. We'd like to, at this point, maybe open it up to those in attendance. Are there any questions or any comments?
Just one of your questions you had or statements earlier that you said the storage aspect in the data center is 1 or 2% of the total BOM. Is that including land, building, or is that just everything in the site?
Yeah, that's just on a single GPU server. It's kind of interesting, right? If you look at this from a hyperscale perspective, I think this is the slide I had in here. From that study from Microsoft and Carnegie Mellon, they said that storage related emissions for storage racks made up 33% of operational emissions for Azure data centers. But for AI data centers, I think there's a question of like what that looks like, right? Where all the growth in IT power is coming from AI data centers and for IT critical power. This was like the semi-analysis one. This was the bond research showing that this whatever, up almost 100 gigawatts of capacity by data center type. And between enterprise, hyperscale, and co-location, it's not like the hyperscalers have all of it, but all the new power is going to AI stuff. So the question of like, okay, how much? If you just the other way to look at that was I had this graph here on just spending, right? I think this was I think even since I made this slide, Meta has upped their spending to like 72 billion for 2025 for CapEx. And I think in that analysis, between 60 to 70% of that spending from the hyperscalers is on IT equipment, and the rest is on data centers, right? So they have a nice breakdown in this study. But so of that, okay, 60 billion per each one of these hyperscalers of the IT equipment, what percentage of that is storage? It's not huge. As far as like compared to the hard, but the absolute number is very big, right? The SSD market and hard drive market are still tens of billions. The storage market will be 100. NAND market is like almost 100 billion or something like that. So with all the different ones combined, right? Consumer SSD, data center SSD, phones, all that stuff. So it's still
Okay.
big, but from a
Right.
new spending perspective, it just gets dwarfed by this when you're looking at projections of like 300 or $400 billion a year on GPUs.
Thanks. So you talked about two things, cost of the BOM and then the energy draw percentage. Got it. Thanks.
Yeah. Um, y-
Well,
yeah, I think this is kind of fun for CDI, right? Whereas, I mentioned obviously
right.
storage is the hardest part. Like if you can solve circularity in storage, we've always said this. Like if you can figure out circularity in storage, figuring out circularity for everything else is like easy. That's the hardest
Well, that's why I was sort of asking,
one.
if somebody says, hey, it's a very small percent of the BOM, they may deprioritize that circularity aspect. So I was just trying to figure out how
Oh,
do you
uh,
not do harm with that percentage?
yeah, we've even talked about like even like we're in a spot where we're like wholesale leasing part of our data center out, and it's like bigger than a colo type thing, but we don't own the data center, so like reporting emissions in scope 1 and scope 2 and all the stuff we've been talking about with sustainability data centers. Like, look, it's up to the data center owner to like help like report that stuff, right? Like they're the ones that know the PUE and the energy costs and the upgrades and doing the calculations and getting suppliers in there to do life cycle assessments and forecasting. But like you said, unfortunately, that's just the truth of it, right? Is people have deprioritized sustainability in favor of just AI growth. And I don't think that's a bad thing for long term for sustainability. I think AI has the potential to solve a lot of these challenges in the long run. I obviously, like think about that all the time. Uh, about like how much of can we use this AI to go do good stuff and help all the gaps in sustainability where we just didn't have the challenge. Like it's helping me do technical research on things that we had AI write us a little bit of software tool that goes out and grabs all the smart information on drives and does a bunch of analysis on it that we've open sourced now, and like AI is helping us do all this stuff that we couldn't do before because now we have
Mhm. Right.
okay. So it will help. It's just yeah, in the short term, data centers are absolutely prioritizing growth. So that maybe it's still the hyperscalers haven't like forgot about sustainability, right? They're still spending hundreds of millions of dollars on carbon credits and trying to hit these goals. But it certainly changed the puck on like these, if they had a net zero 2030 thing, does that throw a wrench, does this throw a wrench into it? Of course, right? They're spending hundreds of billions of dollars.
I guess the other thing too is if it takes 2 years to get a data center up, after what I guess you could do it as fast as maybe 9 months or a year to 2 years, and then it's operating 4, 6 before it gets rehab. There's that whole life cycle, and do they consider the 1 to 2 years substantial enough such that it creates some longevity, or do you waterfall the data centers? It's a really interesting thought. So thanks for letting me spew on that a little bit.
Of course. Yeah. And I'm sure a lot of you guys, other folks deal with, the big guys as well as, smaller regional type colo data centers, customers or partners that have their stuff in there. And yeah, like making this AI equipment fit into a traditional data center, it's not straightforward. We're doing it right now and it's not easy. Like there's a lot of work that needs to be done and the cooling and, we're building our first B200 cluster right now. And yeah, we're doing air cooled because our data center's not doing liquid till we're trying to do it later this year. But yeah, it's very challenging, right? These are extremely a typical storage server or compute server might have been 300 or 400 watts 3 or 4 years ago. Now the B200 server is 14 kilowatts per server. So it's just trying to make that work in a traditional data center. It's possible. We are doing it, but it is very challenging.
That's another reason why we also love the RTX Pro because it's only 5,500 watts per server. You can fit more into a traditional data center and they can compete in this AI market.
Yeah.
Joan, we are doing kind of the waterfall approach. So many of the new AI factories that are coming to us, they want to start today. Hey, I have powered land or I have a facility I can retrofit immediately. Immediately is a year from now, so it takes quite some time.
Yeah.
But they want to enter the AI market as quickly as possible, prove this out with a POC, own their own hardware. So we'll leverage definitely like a regional co-location facility, get them up on their first mini cluster, right? We just did a B200 8 node cluster out of New York while these guys are building out their own facility. And as they're moving towards getting, town approvals, getting N+1, getting their data center up to speed and retrofitting that data center, we can monetize the GPUs that are in New York on a short-term basis and then expand regionally.
All right, friends. Well, thank you very much for tuning in.